Hello, my dear students. Welcome to Prep Yourself. Today, I'm going to teach you chapter number 11, that is light, shadows, and reflection. So just stay with me. I'll explain the entire chapter line by line. Okay? So stay connected and see the whole video. All right. Now, like every other NCERT book, here we have story of two friends. One is Keshav and the other one is Jatin. They are spending their summer vacation at Jatin's grandparents' village. Okay, and they are fascinated. They are, they're full of novel experience by seeing the forest, the fresh air, sound of gushing streams, chirping birds. Why? Because they do not experience such things in the city. However, for Keshav, the most fascinating sight was the dance of 100 fireflies at night. So he saw fireflies were flashing their lights at night as if there was a wonderful performance they are doing. Okay, so Jatin's grandparents explained them that fireflies are seasonal insects, and they use their light to talk to each other or to communicate with each other. They also told them that unfortunately their numbers are decreasing. They are on the verge of extinction. They are reducing in numbers. Why? Due to light pollution, due to reduced forest cover, due to excessive tourism. So students, nowadays we rarely, in fact, we don't spot a firefly in a city. And if we do that in village, and that too is rare. All right. So at the end of their vacation now, they're going back to the city. They boarded a bus. While they are on the bus, they go through hilly roads and they watch the moonlit landscape, and they are very happy to see it reminds them of many poems and songs about moonlight and wonders. And they think that does this moon has its own light, or does it reflect light from somewhere else? Okay, so they are thinking, a lot of imaginations are coming to them, and they also notices something strange, that light seems to move in a straight line. So all those thoughts that is coming to them must be coming to you also. So let us start with the chapter so that we get a clear understanding of light. So light, we will start with the sources. So the natural source of light on earth is sun. So the sun is the main and the natural source of light on earth. All right. Apart from the sun, we have stars, lightning, natural fire, certain animals like firefly who also emit their own light. All right. So in ancient times, human learned to create fire. We all know that the first artificial lighting was by rubbing two stones together, right? So this was done in the ancient by the human, and with time they learned to create fire using different fuels as such as animal fat, oil, wax, and gas. In figure 11.2, you can see fire as a source of artificial light. So natural, we just discussed, stars, lighting, certain animals, and the main is the sun. Here we have artificial light, like you can see, the one we can get from lamps, the one we can get from candles, from diyas, right? So these are artificial sources of light. You can also say, now we have, these were the ancient times, but now we also have something called torch. So torch is also artificial source of light, right? Okay. With invention of electricity and different kinds of electric light sources, as I just discussed, most of the lightning needs of humans are now met by electric lighting. All right. Now, with this, after seeing the sources of light, here we discuss about two categories of object. One is luminous and the other one is non-luminous. Objects that emit light of their own are called luminous objects, whereas objects that do not emit light of their own are called non-luminous objects. All right. Okay, so here objects that emit light of their own are called luminous objects, whereas objects that do not emit light of their own are called non-luminous objects. Now, we also have few examples of luminous and non-luminous object. Like moon is a non-luminous object. The light that comes from a moon is not of its own. It reflects the light that falls on it by the sun. Right? So sun is a luminous object because it emit light of its own, whereas moon is a non-luminous object as it does not have its own light. Is that clear? So here in figure 11.3, there are some sources of electric light in the modern times. Okay, so we have bulb, we have tube, LED lights, etc. Okay, now with LED light, we have a small topic of here. We also discussed about LED in chapter number 3, that is electricity. The full form of LED is light emitting diode. These are lamps are modern light sources that consume much less power, and they are brighter and they last longer than traditional lamps. So if anybody asks you the advantages of LED over the traditional lamps, they are that they consume less power, they are brighter, and they last longer than traditional lamps. All right. And this is not the only advantages. They also reduce electricity bill, and it is also better for the environment. So recognizing the advantages of LED, Indian government has made substantial efforts to promote the use of LED lamps nationwide. Okay, but you need to remember that at the end of their life, you need to dispose them appropriately, correctly. Okay, we should not throw it under in the garbage directly. All right. Now, so the first question which Jatin and Keshav was thinking about after seeing the moonlight, that does moon has its own light? So we already answered the question. Moon does not have its own light. Moon is a non-luminous object. It does not emit its own light. It reflects the light from the sun. All right. Similarly, we have some objects called luminous objects which emit light of their own. All right. So now the next thought that came to their mind was, does light travel in a straight line? So to see this, we are going to do an activity. So let us see activity 11.1. What we need to do is, we have to first take 3 matchboxes and make a hole in the inner tray of each matchbox exactly at the same position. Can you see? At the inner tray, not the outer one. This is the outer one and this is the inner one. So in the inner one, just create a hole at exact same position in all 3 matchboxes. Okay, and then place them at exactly same height like shown in figure 11.4. Now place a torchlight on one side of the matchbox. As you can see, he has placed a torchlight on one side of the matchbox, and place a cardboard. Place a cardboard or screen, you can say, or you can also use a plain white paper on the other side of the matchbox. All right. Now, move one of the matchbox slightly to side or up and down. Are you able to obtain the light spot on the screen now? So students, if you do this, they are at the same height, you will see light will travel through this hole and you will be able to see a spot on the screen. Okay, showing that light was traveling straight into the screen. Now, if you remove from middle or from here any one of them, if you just remove and you still have the torch on, you will not find this spot on the screen. You will not observe that this light spot on the screen. Why? Because light travels in the straight line. Just because you removed one, light was not able to cross through the opaque object and you could not see the light on the screen. Okay, so this experiment or this activity clearly shows that light travels in a straight line. I hope the activity is clear to you all. Okay, now here we have another activity to prove that light travels in a straight line. That is activity 11.2. Now in this activity, you just have to be careful because you're using a lighted candle, so it should be under adult supervision. All right. So what you need to do is take a long hollow pipe of some flexible material like newspaper or some, thin cardboard which can be folded into a roll. All right. Now, what you need to do is place a candle at the end and see through the rolled paper or rolled material or hollow pipe. Okay, so you'll be able to see the light. Now do one thing, you just bend the pipe in the middle. Will you be able to see the light? No, because light will not be able to enter through this bent pipe, which shows that light travels in a straight line. All right. Okay, so here we also have an activity that is done using laser, and use a laser only under teacher's supervision, because lasers which have high power, they are, they can be dangerous because it can cause serious eye damage. So a low power laser is sufficient. All right. So you should never point a laser beam directly in anyone's eye, as it can cause serious eye damage. Now what you can do is you just pass a laser beam through a beaker filled with water, in which a drop of milk is added to make the laser beam easily visible. Now what do you observe? You will be able to see a straight gleam of light, a straight path of light. Okay. However, light can sometimes even bend around the corners. This is something that you will learn in the higher grades. All right. So for now, we have to learn that light travels in a straight line. So this is the third activity which proves that light travels in a straight line. Now, let us understand a category of materials. Materials are classified in three categories. Okay, number one is transparent. Transparent. Number two is translucent. And number three is opaque. Okay, so we have transparent, translucent, and opaque materials. Okay, now the question is, what happens when object comes in the path of light? When these materials or these kind of objects comes in the path of light, what happens? So let us see with the help of an activity, that is activity 11.3. Here we are going to take different types of materials like cardboard, paper, glass, tracing paper, thick cloth. Okay. Now, what we need to do is we have to classify them as transparent, translucent, or opaque. So, students, objects that do not allow to see through them, they are opaque objects. Okay, like if you have a cardboard in front of you, will you be able to see what is behind the cardboard? No. So those objects that does not allow you to see through them or to see what is behind them, okay, those objects are called opaque. So cardboard is an opaque object. Objects that allow to see through them, but not very clearly. They are translucent object like tracing paper or butter paper. Sorry, translucent. Okay, and objects that allow to see through them clearly are transparent objects like glass. All right. So paper again does not allow to see through it, is opaque in nature. Thick cloth again does not allow to see through it, is opaque in nature. All right. Now we have to find whether light will fully, partially, or will not pass at all from these objects. As I told you, opaque objects are those objects that does not allow us to see through them. That means it does not allow light to pass through it. Okay, so and if you take these objects and perform the activity, you will observe that cardboard does not allow light to pass through it. So the answer will be not at all. No light at all. Paper again, because it is opaque, it will not allow any light to pass through it. Glass, because it is transparent, it will allow all the light to pass through it. So fully. Okay, tracing paper, as I told you, you can see through them but not very clearly, so it allows light to pass through them partially. Again opaque, not at all. Same way, you can take multiple materials and find out whether they are opaque, transparent and translucent. Okay, now here we have an activity, that is activity. Okay, here you can see what we are doing. We have taken a ball and we are passing light. Okay, so what do you see? That light, wherever the light is passing, around the corners, you can see that it is on the paper, but the object that is blocking the path of light, there is absolute darkness, right? So there is no light at this portion of the paper or the screen. Okay, you can do it for multiple objects, and you can, with this you can get a clear understanding of transparent materials, translucent materials and opaque materials that does not allow light to pass through it. So now here, what happens when an object blocks the path of light? There is a formation of shadow. As you can see over here, a shadow of the ball is formed. Similarly, if we stand in sun during day in sunlight, we see our shadow on the ground. So now let us learn about how shadows are formed. Okay, so in 11.3 activity, we saw that when an opaque object was placed in the path of light, a dark patch was formed on the wall. And what was that dark patch? That dark patch where the light does not reach is shadow. So students, when shadows are formed when light does not pass through an opaque object. Okay, so when the path of the light is blocked by an opaque object, a dark patch where light does not reach forms on the ground or on the wall or on the screen. That dark patch is called shadow. Okay, so we have noticed our shadows, we have noticed shadows of other objects when we are in the sun or when we are under street light, etc. Okay, so here again we have an activity where we will see, collect some opaque object of different shapes and size, and we will see their shadow formation. Okay, so let us see. what do we have? What you need to do is first collect opaque object of different shapes and sizes. Okay, and you repeat the activity 11.3, that is, you show them some torchlight and put a screen behind. You will observe the shape and size of the shadow on the screen. Okay, so did the shadow form in all cases? Was the shape and size of the shadow same as all the subjects? We have to write our observation in table 11.2. Okay, so the screen is removed. When the screen is removed, will you still be able to see the shadow? If there is a screen on the other side, you will be, otherwise no. Okay, the object is removed, obviously not, because light will pass through it, so you will not see a shadow when the object is removed. When the torch is switched off, no, you will not be able to see the shadow if there is no light. All right, so for shadow formation we need a screen, we need an object, and we need a source of light. All right, same way here there are so many questions which you can just do the activity, see for yourself, and write your observations in this table. Okay, so the conclusions that you draw from the activity are: shadows are formed when an object blocks light from falling on a screen. So we need, as I told you, we need a source of light, number one, we need an opaque object, number two, and we need a screen, number three, to observe a shadow. A screen can be walls, floor, ground, any other surface can act as a screen for observing shadows in our daily life. All right, and the shape, sizeness, sharpness of the shadow will depend on the position of the object to the light source. Okay, and what kind of object it is, the shape will be according to that object. All right, now changing the color of the opaque object does not change the color of the shadows. Okay, because shadows are formed just by blocking the path of the light, so color does not matter. All right. Now, we have learned about shadow formation. Now we will learn about reflection of light. So to understand reflection of light, let us do an activity. What we need to do is we find a shiny plate or a plain mirror and we take it outside and let the sunlight fall on the shiny surface. Okay, so what do you see when you take it in the sunlight? You will observe that the light will be reflected. The sunlight that is falling on the mirror or the shiny metal plate will be reflected and can be seen on a screen or a wall in the opposite direction. Okay, so what does this mean? If you tilt the shiny plate, you can see the light spot at different positions of the wall. So the conclusion that we draw is that a shiny surface or a mirror changes the direction of light that falls upon it. This change in direction of light by a mirror is called reflection of light. Okay, so what is reflection of light? Bouncing back of light. Bouncing back of light into the same medium. Okay, is called reflection of light. Okay, and when does it happens? It happens when light falls on an opaque shiny surface or a plain mirror. Okay, so here we perform this activity with the help of a mirror. Can you see this? Activity 11.6, we have made a thin slit on a black opaque paper. We are passing torchlight through it and you can see straight beam of light passing through it. Now what do? We take a plain mirror in front of it. When we take a plain mirror, you can see the light is incident like this. And what happens to the light? It reflects back like this. Okay, so what do you see is is the bouncing back of the light into the same medium when light falls on a plane mirror. This is called reflection of light. So what is the light doing? It is changing its path after falling on a mirror. Okay, so reflection of light occurs at the mirror. You can also see your face in the mirror. Is it due to the reflection of light? Yes, absolutely. So now we will see how images are formed in a plane mirror. What you need to do is you look into your mirror. What will happen? You see your face. Or if you put any object in front of the mirror, what do you see? The image of that object. As you can see, the image of a pen in a plane mirror. Okay, so now what can we say about the image form? What are the characteristics of the image form? Let us learn about the characteristics of the image formed. So first, let us learn about the size of the image. Number one, size of the image. So if you look at the size of the image, it is the same as the size of the object. If you don't trust this figure, why don't you try standing in front of the mirror and see if your image is of the same size as you are. Okay, so students, when we see or when we compare the sizes of the image and the object in front of a mirror, we find that the image formed by a plane mirror is of the same size as the object. Number one. Okay, so this is the first characteristics of image formed by a plane mirror. What is the characteristics? That the image formed by a plane mirror is of the same size as the object. All right. Now, the next one. The next one is, what is the nature? How does it appear? Does it appear inverted or does it appear erect, upright? How does the image appear? So again, if we see the image in figure 11.10, we see an upright image of the pen. Okay, so upright means the top appears to be the top and the bottom appears to be the bottom. Okay, when we stand in front of a mirror, we see our face at the top and our legs at the bottom. Have you ever tried this? You just stand in front of the mirror. Will you see your leg at the top and head at the bottom? No, we see head at the top and legs at the bottom, just as we stand. So this kind of image is called an upright image or an erect image. Okay, so number two, a plane mirror always formed an upright image, upright or erect image. Okay, so what we can say is an image formed by a plane mirror is always erect or upright in nature. Okay, now what we need to do is another activity, that is 11.8. You stand in front of a plane mirror and look at your image. How far it appears to be from the mirror. You stand close to the mirror and now you see that the image comes closer to you. You go back, you see your images go back. And how much? If you move back 2 steps, your images also move back 2 steps. If you move back 10 centimeter, your images also go behind the mirror by 10 centimeter. Okay, so with this activity, what do you realize? That the distance of the object from the mirror is equal to the distance of the image from the mirror. Let me explain you with the help of the diagram. This is the object. Suppose, let me go to that pen figure. Yeah, so this is the object. So the distance of object from the mirror is suppose 2 centimeter. So the distance of the image from the mirror will also be 2 centimeter. All right. So this is the third characteristic feature of the image form. Let me write it over here. The distance of object from the mirror and the distance of image from the mirror is same. That means if the object goes closer, the image also comes closer. If the object goes farther, the image also goes farther. All right. Now, another thing that you must have noticed, that if you raise your left arm, your images raises its right arm. And if you raise your right arm, your images raises its left arm. If you touch your right ear, the image will touch its left ear. If you touch your left ear, your image will touch its right ear. This characteristic is called lateral inversion. Okay, due to lateral inversion, you see, if you notice ambulance, or you see on ambulance, the ambulance is written like this in inverted letters. Okay, why? Because if you view it from the rear view of the vehicles, it appears straight. So this feature is called lateral inversion. Suppose there is a mirror like this, and you put an alphabet B in front of it. So the alphabet will appear inverted. Okay. Same way, if in front of the mirror you place an inverted P, so the P will appear like this. Okay. So this property of the plane mirror is called lateral inversion. Here the right appears to be the left and the left appears to be the right. Okay. Is that clear to all of you? So this is lateral inversion. Now we will study about pinhole camera. So what a pinhole camera is? A pinhole camera is basically a device in which light rays passes from an object through a tiny hole, which is called the pinhole, and it forms an image on the screen. Okay, so let us draw a pinhole camera. How can we construct a pinhole camera? Before constructing, there is an activity which you can perform. What you need is, you need a candle, you need a cardboard and a screen. Okay, light a candle. Do this experiment in adult supervision, because fire is something very dangerous, and the adult should be there while you are doing any activity with it. Now on the cardboard, make a small hole. Place the lighted candle in front of the pinhole, and on the screen you will see the image of the flame. What is so different about the image? You see that the image is inverted, that is upside down. Okay, now let us make a pinhole camera. How do we make a pinhole camera? You see, you take two boxes of different sizes in a way that one box can slide inside the other box. So this blue box is smaller and this pink box is bigger, so that blue box can slide through the pink box. Now in the blue box on the opposite side, make a pinhole. Okay, and from the open side, you slide the small box. On the opposite side of the small box, make a square or rectangular cut and place a tracing paper like a screen. Okay, and now you slide it inside. Now what you do is, you cover your head with a dark paper and try to look through the pinhole. Suppose there is a distant object like a tree or a building in bright sunlight. You move the smaller box forward or backward until image appears on the tracing paper. Okay, so what do you see? There is an image formed. Is the image erect or upright? The image will be upright. It will not be upside down, but the image will be laterally inverted. Okay, we will be learning more about this. Why this is happening? What is the phenomena behind this in higher grades? Okay, so for now, We will keep it till here, and we will learn to make some useful items with the learning which we came to know about light, that light travels in a straight line and it is reflected by mirrors. So what can we create with these learnings? We can create a periscope. We can create a kaleidoscope. So students, periscope, it is a simple device which is made by placing two plane mirrors in Z shape. As you can see in figure 11.14, we have placed a plane mirror over here and a plane mirror over here. Okay, so what happens, you use this periscope is in this. So if you see from here, you can see what is behind this wall using the periscope. Okay, so how does it happen? Suppose you want to look at these trees. Okay, so the light from the trees enter into the periscope and falls on the mirror. And as we know that light gets reflected while falling on a plane mirror, so it reflects back in this direction, and it again falls on a plane mirror and again reflects back in this direction and reaches the observer's eye, and hence we can see the image of the tree from this point. All right, this is how, people in submarines, tanks, soldiers see outside their bunkers using a periscope. Okay, so you may use it to look ahead when standing behind taller friends or walls. Okay, now coming to kaleidoscope. Kaleidoscope, I have one kaleidoscope, but I cannot show it to you right now. So let us see this, how we can make kaleidoscope. In kaleidoscope, we will need three rectangular plane mirror. You can make it at your home. Okay, so plane mirror strips of equal width, you join them together in a triangular manner as shown in figure 11.15a. Okay, so here we have, see, this is one plane mirror, then at the back this is one plane mirror. Okay, and then at the bottom it is one plane mirror. So three sides, 1, 2 and 3. So we are using three rectangular plane mirror strips of equal width and you're joining them in a triangular manner. Okay, now fix these in a circular tube of thick chart paper. As you can see, this is a circular tube of fixed chart paper and we put it inside that circular tube as in figure B, 11.15b. On one end of the tube, fix a transparent plastic sheet using a rubber band. So at one end, just place a plastic sheet using a rubber band or an adhesive tape. Place several broken pieces of colored bangles or beads on this. Okay, and cover it with a tracing paper using a rubber band or an adhesive tape. When you peep through the open side, what you see? You view beautiful pattern. Okay, even if you leave both sides of the kaleidoscope open and pointed towards a tree or objects, you see beautiful patterns. An interesting feature of kaleidoscope is that that one always gets to see different pattern every time the kaleidoscope is turned about. All right, why? Because there are three mirrors and multiple images is formed due to multiple reflections and reflections of reflections. Okay, so you can see interesting patterns. Designers and artists, they use kaleidoscope to get ideas for new patterns. All right, so that's end of the chapter. In my next video, I will discussing with you the NCERT exercise questions. If you have any doubt, please make sure you put it in the comment section and I'll help you out with that. Take care and bye-bye.